So this is a sensing cane for blind people. It has an ultrasound sensor at the end, so it will pick up objects nearby it, and the data that produces in centimeters will go through here to the microbit. It will map that data to the sound output, which we've plugged in headphones to this headphone jack. It will create a beeping. The higher frequency the beeping, or the closer the object, the higher frequency the beeping will be, and also higher pitched. We've also added a electric toothbrush, which we've used as our haptic feedback vibrator, so that when you hold it, you put your thumb on here, like this, it will vibrate, and the higher the frequency of the vibration, the closer the object is.
What inspired you to create this?
We were just thinking of problems in the world and thought we could build something to help blind people. Originally our idea was a mobility scooter for blind people, but we thought that was a bit too big for 1 week, so we just made this. So that's our code that we've written.
What did you use to code it?
Microbit, just block editor. We thought that would be the best for the time, because we only had a week.
What improvements could you make on this in the real world once you got it into production?
We would make everything more compact, maybe inside the cane for protection, and make it easy to look more appealing. The sensor would work a lot better. We'd use a higher quality one because it's only a McDonald's sensor. We'd probably add external buttons, because at the moment these two buttons will toggle on and off either the sound done by this one or the vibration done by this one.
And are there any technological innovations you could introduce? Like smaller earphones and...
Yeah, well, we can do that at the moment because we've added a headphone jack here so that we can unplug these headphones and just plug in different ones. We were thinking we'd also try and enable Bluetooth onto it so that you could have Bluetooth headphones or earplugs or something like that. Another good thing about this haptic feedback is that when a blind person picks up the cane, they feel for this part, and then they know which way the stick is facing, so that they know they're pointing the stick the right way.
And what's different about the technology you're using, particularly the sensor?
Yeah, the sensor uses ultrasound, so that it will send out a pulse of sound that humans can't hear, and it will wait for the echo to come back of that sound, and then using the time it took for the echo to come back, it would generate a value in centimeters, which the microbit takes to do everything.
And what have you enjoyed most about coming to the Hydrogen Hack?
I've learned a lot of new stuff. We've learned a lot of electronics, how a lot of the circuits work and what makes them work. Also learned about hydrogen fuel cells and seen lots of different things about them. Do you want to see now how the code works?
Yes, please.
So here, it will forever set the value of distance in centimeters to the output of the stick. So all the things like P2 and P1 and P8 down there, they're all pins from the microbit, so that they're basically gates for the information to pass through. It's going to output into centimeters, in centimeters. Then we've got here, so if sound toggle, which is basically the toggle, I'll show that later, and distance is the less than 1.2 meters, so we don't want it detecting things that are all the way over there. Then what it will do, it will play a tone for a 16th of a beat, and it will map the distance in centimeters from 0 to 1.5 meters to the pitch of the sound. So the lower the distance will be to the object, the higher pitched it will be, and the further away it is, then the lower pitched it will be. So it will play one tone or one beat for a 16th of a beat. Then, at the end, the way the frequency works, which this also works for the vibration here, is that it will pause the code for 3 times the distance. So say it's like 10 centimeters away, that number will be 10. 3 times 10 will be 30. So if it's 10 centimeters away, there will be a 30 millisecond pause between each beep and each vibration. Then once that pause is done, all of it starts again. Here is the way the vibration works. If vibration toggle and distance is less than or equal to 5 centimeters, I'll explain that later. Then, well, this is the main part of it. It's vibration toggle and distance is less than 1.2 meters. Then it will write pin 8, so that send a signal to the vibrator, set it to 1. It will pause for a 16th of a beat, so it's synced with the sound as well. And then it will clear that information, and then that will keep on repeating for the amount of distance. So, like the lower the distance, the lower the pause will be. What this bit here does is that if the distance is less than 5 centimeters, instead of having it just turn off and on and off really fast, we've just set it to it will have it constantly on if it's less than 5 centimeters.
Okay. And tell me about the one missing person here, who should have been here today.
Oh, Joseph. He went on holiday.
A bit more.
What?
Tell us more about how you worked with Joseph on this week and how much fun you had.
Okay, so he was quite good at mapping out everything out, like the way the circuit works, so that we can rewire it a lot faster. So he wrote down every single pin that each wire was connected to and where each one went. So I wrote this code, but I also, while doing that, I explained to him how it worked, so he understood how the code worked and he managed to recreate it.
And any words for Arcola?
They helped us to do this. Yeah, thanks Arcola for helping us.
Brilliant. Thanks very much, Chris. It's really interesting.
What won it for us was a project which, really showed imagination, showed creativity, but also showed the ability to integrate that and the full spectrum of possibilities of these devices, and everything that they could do, and everything they could sense, and everything they could output in a device that really was beautifully made and had an incredible sensitivity, and we were all just bowled over by it. And so the prize for Best in Show, and prize for Best in Show, as well as for the most number of syllables in their name, is Sententia for Rudy.